students, we are discussing about some problems from the chapter machines. These problems are taken from Conscience Physics book, class 10 ICC. Okay, so now let us come to the problem number 1. What does it say? Given it is a 4-meter long rod of negligible weight is supported at a point 125 centimeter from its one end, and a load of 18 kg is suspended at a point of 60 centimeter from support on the shorter arm. Okay, so just draw the figure. What will be it like? So let us take solution number 1. First of all, for this kind of problem, the diagram is very important as it can actually help you to solve the problem easily. So a 4-meter long rod, this has been given that there is a 4-meter long rod. Okay, so just draw a rod, consider a rod. It is 4-meter long. So can you guess that, you know that 4 meter is actually equal to 400 centimeter, isn't it? So the total length of this rod should be 400 centimeter. Fine. Now this rod is being used in this problem, and let us see what are the given informations. It is supported at point 125 centimeter from its one end. So if I consider this as the 0 mark, these are the 0 marks, so 0 centimeter, and this end should be 400 centimeter. So this end is 400 centimeter. So it has been balanced at a supported at 125 centimeter mark, so it's less than half. So if I consider just the middle point to be this, okay, then 125 centimeter, 500 half, it's 200, 400, 200 half, it's 100 centimeter. 125 centimeter would be slightly this side. So this is, say, let us consider this is 125 centimeter. Okay, fine. Now here it has been supported, or you can say rather it has been balanced at. So just if I consider it to be balanced at the 125 centimeter mark. Fine. Now from its one end, a load of 18 kg is suspended at a point 6 centimeter from the support. Okay, on the shorter arm, 60 centimeter from the support. Okay, 18 kg, 60 centimeter from the support. So here is the 18 kg load suspended. Okay, here is 18 kg load suspended. This is 18 kgf, and this point is actually, what will be this point? This point is not actually 60 centimeter. It is said that this point is at a distance of 60 centimeter from the support point. So actually this gap, okay, this gap is 60 centimeter. This total gap is actually 60 centimeter. Okay, so this is 60 centimeter. Fine. Okay, now what it is said, it is asked in the first part of the question that if a weight W is placed at a distance of 250 centimeter from support on the longer arm, 250 centimeter from support on longer arm, 2 centimeter from support on longer arm, so 250 centimeter. So just let us consider, so 250 centimeter, if I say that it will be some distance like this, 250 centimeter. So if you just add 250 to 125, you will get this position. Okay, so a weight of W is being put over this point. Okay, weight of W. Okay, so 250 centimeter from the support point, okay, has been put out. Then it is said, and it is in the balanced condition, then it is said that what is the value of the weight W. Okay, so if I now come to the first part of the solution, what I have to do, I have to, so you have drawn the figure, so we have to actually apply the law of equilibrium, principle of moments, and principle of moments, which says that the total clockwise moment is equal to total anti-clockwise moment. So this 18 kg, this 18 kg, this 18 kg is actually producing an anti-clockwise moment, isn't it? And this W is producing a clockwise moment. Okay, fine. So if I just consider, so what will be the total clockwise moment? Total clockwise moment, CW moment, is equal to W into 250. Don't subtract it because it has been already said that W is at a distance of 250 centimeter from the support. So the distance is itself given 250 centimeter. So if I consider the weight to be in kgf, just consider this weight to be in kgf. Okay, so we can say that it is kgf centimeter. Okay, fine. Now the anti-clockwise moment, ACW moment. What will be the anti-clockwise moment? It will be 18 into 18 into 60 because the distance itself has been given as 60 centimeter kg centimeter. So by the by principle of principle of moments, we can say that clockwise moment is equal to anti-clockwise moment. Okay, so we can say that W into 250 will be equals to 18 into 60. So from this you can calculate the value of W as 18 into 60 by 250. So I will not be doing the calculations. I will leave the calculations to all of you. You can solve the problem and mention the answer in the comment box. Okay, so this will be the value. Okay, so let us just see. So this is the value of the W. Okay, so this is the first part of the problem. Now the second part is, if a weight of 5 kg is kept to balance the rod, find its position. Okay, then it has been said that if a weight of 5 kg is kept to balance the rod, then you have to find its position. Okay, so the next question says, instead of W we are using a weight of 5 kg, isn't it? Then where do we have to place the weight of 5 kg? Okay, so in the second case, actually second part of the problem, what you have to do, you have to consider a weight of 5 kg. So we do not know its position, we have to consider its position. Okay, so let us say that the weight 5 kg is placed at a distance of say x from the support on the longer arm. Okay, so coming to the solution number part 2 of the solution, let 5 kgf be placed x centimeter from support on longer arm. Obviously this has to be placed on the longer arm, as because only then it will balance the 18 kg. So by now, again according to principle of moments, by principle of moments we can say that by principle of moments we can say that 18 into 60 now will be equal to 5 into x. Okay, so from this you can say that the value of x will be equals to 18 into 60 by 5. Okay, so this is the solution. Again I will leave the answer, I will leave the answer, I'll leave it for the answer to you. Okay, you just solve the problem and give the answer in the comment section. Okay, so this much of centimeter. Okay, so this will be the answer, 18 to 60 by 5. I hope you can do the numerical value. Okay, now the third part of the problem says that which kind of lever or which class of lever does it belong to. Now there are three classes of lever: first class, second class, and third class. Okay, class 1, class 2, and class 3. Now see, as because you can see that the fulcrum is in between the load and effort, you can consider one force as the load and the other force as the effort. So you can say that the fulcrum, as the fulcrum is in between the load and effort, as fulcrum is in between load and effort, fulcrum is in between load and effort, load and effort. Okay, so you can say that it is a class 1 lever. It is a class 1 lever. Okay, so I think the solution is clear. Fine. Now let us move on to the next question. Question number 2. Okay, so let us come to the solution number 2. Okay, so what does question number 2 says? A fire tongue has its arm 20 centimeter long. So first of all, I want to say what is a fire tongue. A fire tongue, I think you all of you have seen the device which is used to give sweets in the restaurants or in the sweet shops. Those are called the tongs. Okay, so fire tongue is something like that. Instead of carrying sweets or instead of just giving sweets, it is used to hold coal. Okay, so it is said that a fire tongue has its arm 20 centimeter long. So first of all, just let me give a schematic diagram of a fire tongue. It is something like this. Okay, it is something like this. Fine, this is the fulcrum point. Okay, and this is the point where the coal is hold. Okay, so this point actually acts as the fulcrum. Okay, the effort is applied somewhere here in between. Effort is given somewhere in between, and the load is held in between these 2 points. Okay, the load is held in between these 2 points. Okay, okay, fine. So the load is held in between these 2 points. Fine, so this is the load. Okay. Now if I say that now the length of the fire tongue has been given as 20 centimeters, so length of the fire tongue, so overall length is given as 20 centimeters. So just I can say that this length is 20 centimeter. Fine. Okay, now the load has been given as weight 1.5 kg, that is the weight of the coal, applying an effort at a distance of 15 centimeters from the fulcrum. So the effort is applied at a distance of 15 centimeters from the fulcrum. So basically this point is actually the effort distance from here up to this point. Okay, so this is, I can say that this is 15 centimeter. Fine. Okay, so this is 15 centimeter is the effort distance, isn't it? So I think you can easily understand from this figure that the load arm, that is the distance of the fulcrum from the load, is 20 centimeter itself, and the distance of the effort arm, or the length of the effort arm, is distance of the effort from the fulcrum, it is 15 centimeter. Now, so from this figure you can say that if you just write the given conditions, you can say given is, what are the things given here? First of all, load L will be equals to 18 kgf. Second is the load arm. Second is the load arm, LA. So it is equal to 20 centimeter. Third is the effort arm. It is given as EA. It is equal to 15 centimeter. Okay, 15 centimeter. Fine. Now what we have to find out? We have to find out the mechanical advantage of the fire tongues. MA refers to mechanical advantage. So mechanical advantage, as we know, this is a, in general, mechanical advantage is equal to load by effort, but as this is a lever, this particular machine acts as a lever, so we can write that mechanical advantage is equal to load by effort, and that is equals to effort arm by load arm. Okay, so what is the value of the effort arm? It's 15, and value of the load arm is 20. So if I just simplify it, 3 by 4, the value comes out to be 3 by 4, that is equals to 0.75. so this is the value of the mechanical advantage. Okay, fine, great. And what is the second question that has been asked? Second question is given here as effort needed. Okay, so you know that Mechanical advantage is equal to load by effort. So you can say that mechanical advantage is 3 by 4, isn't it? And what is the value of the load? It's 18 kgf. We need to find out the effort by E. So, or this implies that E is equal to, so it will be 18 into 4 by 3. 3 6 the 18 and 6 4 the 24. So 24 kgf is the effort applied. Okay. So this is the second solution. So I think the solutions are clear to all of you. If you have any doubt or query regarding these solutions or any other regarding regarding or any other query regarding this topic, you can mention it in the comment section. We will definitely try to solve your problem. So in the next class, we will be continuing with some more problems from machines. We will be mainly doing problems on pulley. Till then, goodbye.